The idea of transplanting stool from one person to another as a medical intervention sounds, on first encounter, like something that belongs in a different century. And yet, fecal microbiome transplantation has already demonstrated clinical efficacy compelling enough to earn FDA approval for recurrent C. difficile infection, a condition that kills tens of thousands of Americans annually and that had resisted conventional antibiotic treatment in its recurrent form. The question now being seriously investigated is whether the same logic extends to the brain, and the early evidence suggests that it might. The biological rationale begins with the gut-brain axis, which is a more literal communication highway than most people appreciate. The vagus nerve runs directly from the brainstem to the gut, transmitting signals in both directions. Approximately 90% of the body's serotonin is produced in the gastrointestinal tract, not in the brain. The microbiome produces neurotransmitter precursors, regulates inflammatory signaling that crosses the blood-brain barrier, and modulates immune responses with documented downstream neurological effects. The gut is not a passive digestive organ. It is an active participant in neurological regulation. The animal research in this area is striking enough to demand serious attention. Studies demonstrating that transplanting gut bacteria from anxious mice into germ-free mice transfers anxiety-like behaviors, and that the reverse transfer reduces them, establish a causal microbial contribution to behavioral states that goes beyond correlation. These are not subtle effects at the margins of statistical significance. They are robust behavioral phenotype transfers, and they have been replicated across multiple research groups. Human trials are necessarily earlier stage, but signals are emerging in autism spectrum disorder, treatment-resistant depression, and multiple sclerosis. None of these trials yet support clinical practice changes, and it is important to say that clearly. But the convergence of mechanistic plausibility, strong animal data, and early human signals represents a research trajectory that would be scientifically negligent to ignore. The regulatory complexity here is genuinely unusual. FMT occupies an uncomfortable position between a drug, a tissue transplant, and a living biological product, categories that trigger different regulatory frameworks with different evidentiary requirements. Standardizing donor screening, processing protocols, and delivery methods for psychiatric applications presents challenges that the C. difficile experience only partially addresses. Mental health outcomes are also considerably harder to measure and attribute than the binary recurrence metrics used in infectious disease trials. The warning worth issuing is about the gap between public enthusiasm and scientific maturity. Microbiome science generates intense public interest, and that interest has created commercial ecosystems of probiotic and FMT-adjacent products marketed to consumers with mental health concerns. The distance between animal studies suggests microbial influence on anxiety, and this probiotic supplement will treat your depression is vast, and that distance is being systematically obscured in marketing language. The science deserves to be protected from the commercial noise surrounding it, because the actual research is interesting enough to stand on its own merits.